So here is how Dora, the explorer, would explain transport layer security. So, and this is just too funny. First, you and your friends say hello to each other. You share some secret information. Well, if we look over here, what's happening here? Client says, hello, I'd like to share some secret information. Here's the sort of things that I can do and the versions I can use, and it says it to the server. So, well, that's great. Let's pick this one from your list. We can all get together and do things, and here's my certificate. So how different is that from this part right here?
Yeah,
Not at all.
Same.
It's the same thing. So now we show each other our secret decoder rings. Well, we're verifying our certificates. We're getting our public keys. And then between the two public keys that are available, we're creating what's called a pre-master key. Because this is all asynchronous right now. And so in this case, we're sharing each other the secret decoder rings. They have special symbols on them. So now we're deciding on the pre-master. Well, the pre-master key is like going into see, we're at asymmetric right now. To get into symmetric encryption, which is what we want because it's really fast, we have to somehow exchange a secret key. So that's this point. You're deciding on a secret key. So that's this part right here. We verified, this client verifies this guy's certificate. As this guy says, yep, here's my certificate. I'm a good guy. I'm verified by the certificate authorities. And we've agreed upon the type of decoder rings that we're going to use, right? So then client says, yep, that certificate is in my browser because that's where the certificates are stored. So when you're on a browser, your secret decoder ring is in your browser.
And it encrypts the pre-master key.
Right. So the pre-master key is it encrypts because that's not really the key we're going to use. It's like we're getting there. So this lets us send stuff back and forth before we get the shared secret going. It lets us encrypt our information. Right. So we've encrypted this using the client uses the public key. This guy's public key. Server's public key to encrypt it because he's given us his public key. And so now we encrypt I'm sure it's some sort of a random key based on an algorithm, sends it to here. So we put together some gobbledygook that's temporary. And then we use this guy because it can only be decrypted with the private key. I can encrypt with a public key.
Yeah.
But I can't decrypt it.
Yeah, it should be decrypted with a private key.
So we're still kind of exchanging decoder rings at this point, right?
Yeah.
This is where we're showing each other the decoder rings. We're determining what's our secret key. So we're in the handshake where, okay, we are agreeing on how we're going to communicate. And then the server uses its private key to decrypt that. Okay, now you both have that pre-key and you use that to compute the actual shared secret key. Because now you're communicating encrypted.
So in the beginning, it was asymmetric and it's becoming symmetric.
Right here, when we get the shared secret, then we're going to become symmetric.
Yeah, okay.
So this is all handshaking and negotiating, and here's my secret decoder ring and keep it away from the squirrels and all that sort of stuff. So now we both use that pre-master key because we both have it to compute another key, which becomes the shared secret key. Which is like, we're at the point where we can send secret messages and put them inside locked boxes, but it can only be opened with your secret key. And they use their secret key to unlock it and read the message. But you have the same secret key going back and forth. They're saying each has their own secret key, but really they both have the same secret key on each end because we use the asymmetric exchange to create an encryption that we then could share our symmetric key back and forth securely. So our decoder rings are now synchronized.
And it will work faster than just asymmetric.
Asymmetric has lots of stuff going on. Symmetric encryption just goes zip, 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 and it's done. So now we're at the point where, yes, here's an encrypted message, try to decrypt it, verify that everything's good. Everything from this point on is going to be encrypted using our shared secret. oh, yes, look at here, everything is good. Well, this is not the end of it. I mean, the encryption key rotates.
Mhm.
It doesn't ever stay the same. But if you just have a short time on there, it's, it's probably not going to change. But part of all the encryption suites that we have now is that the keys rotate. You wouldn't, like, every time you go onto Amazon, as you're on Amazon, depending on how long you're on there, the key may rotate to another key.
Mhm.
So it's never going to be the same one.
They just redo handshake and
Yep.
exchange
There's
another key
probably a timeout for a secret key or something.
because it's more secure, because it could be intercepted
Mhm.
somewhere in process, and it's better to change the key in some period of time.
Yep. And my experience with that is setting up VPNs. You can set up VPNs.
Mhm.
You have to somehow exchange the secure keys. If you're not using certificates,
Mhm.
all the secure keys do is generate the encryption.
Mhm.
They're never exchanged because you know them on each end, but every so often that
Mhm.
generated encryption changes. So could be like we're using the pre-master key to compute another shared secret key, might be a way to think about it.
Mhm.
So on in VPN tunnels that are open a lot, they have a certain time where they'll rotate and regenerate a new one, regenerate a new one, regenerate a new one. Because if you kept the same one 24/7, 365 days a year, eventually somebody could break it. So that's why you use the asymmetric part. Well, if you have shared keys, so it's like rotating. The shared keys are used to encrypt, to create the encryption, to use the algorithm to create the encryption. But there's also another like secret key that's set back and forth.
Mhm.
And so that part can get changed. Okay, I lost myself there. Anyway, what if somebody tries to steal our secret decoder rigs? Well, we have to watch out for the squirrel sneak attack. Everybody's read about that recently. That's one of the big, they got into the government and all kinds of stuff with the squirrel sneak attack. But it's okay because we get intruder alert. The ring knows it's in danger. Yeah, well, anyway, I think we're diving a little too far off the beaten path here, but it's pretty funny. This one's actually pretty good because if this is like we're now changing our secret symbols, it's like we're changing that shared secret encryption. We're rotating through different combinations. So that's kind of what that's like. Okay, so that was pretty funny. Who knew AI could be so useful? And this is another one that shows the same thing. So we have a client, we have a server. This is pretty plain Jane compared to what we've just done. So the client says, hello. And that's very common. They call it a hello. This is your beginning handshake. It says, here I am. Here's my ciphers. Here's a random number. Here's my ID. Here's all the stuff that you need to know in order for us to start communicating. It's like, hello, Philip. Hello, Philip. Hello, ma'am. My name is Bill. I'm a instructor at community college, blah, blah, blah. It's like they're introducing each other. So that's why they use the hello analogy. Well, then the server says, well, here's my selected ciphers. Here's my blah, 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 blah. Here's my certificates. Okay. And then the server says, okay, we're good to go. We have the client. This is not as good an explanation as the other one, is it? So we we have an encrypted pre-master secret that allows, this is not as good an explanation. But we use this to generate our keys.
Mhm.
We exchange and we're finished. Then we go into we're actually sending information. So this is the handshake. They call this the record. This would be asymmetric. This is symmetric, where we're actually transmitting the data. All of this is just overhead getting started.
Yeah.
And because we're using public-private key certificates, we don't ever have to exchange anything. It's all handled as part of that public key encryption. This adds on the SYN-SYN-ACK. At the end, they did not put the other one, but does anybody remember what SYN-SYN-ACK means? What's that all about?
Synchronize, acknowledge, or something.
Yeah, it's a three-way handshake for TCP communication. So you send the synchronization packet, the server sends an acknowledgement saying, I got your synchronization packet.
Mhm.
And then it says, I am going to send an send packet to you. Then you acknowledge that we're communicating, and then we've got our initial TCP handshake.
Mm.
Because it has to be TCP for this sort of thing. And then it does the client hello business. Well, that was interesting. Yeah.
So that means that The IP address exchange before, the hello, like the ancient.
IP addresses don't change. This has nothing to do with IP addresses.
But for the client to exchange with the receiver doesn't need like to know the IP address of the receiver.
We have to know the IP address of the server. Right, so if I go to google.com, my computer knows the IP address of the server, right? Because I have started the communication, part of my packet says, this is how you get back to me, here's my IP address. So yes, that's part of the initial exchange of, I live in Scotts Bluff, you live in the dorms, we're letting each other know where we are. Is that what you're asking?
Yeah.
Okay, sorry, I was misunderstanding a bit there. Okay, so anyway, there's that part, and then eventually it gets down to here. I just thought, oh, that's interesting, they have the three-way handshake. But that happens with every TCP communication, so there's two different types of transport protocols. TCP is Transport Control Protocol,
Yeah.
UDP is User Datagram Protocol.
Data, yeah,
I'm using UDP right now with all my zooming and stuff.
yeah,
Because it just needs to get, most of it get there. If I'm missing a few bytes here and there, who cares? But am I going to go to Amazon and purchase something through UDP? I care if it's 10,000 or 1,000 or 100. So yes. We do use encryption with UDP. It is not quite the same as this. And then here's my last one. This is kind of like this one over here. I thought these are all pretty good. This one, I only like that it had the syntax sin on the end. And that would have FIN at the end, meaning we're finished, or RST reset. So this goes through the same sequence. We check the certificate. See, each of them does a little bit different. We send our information. What's our supported cipher? And we send a random number. The server says, let's use this cipher. Here's my random number. Okay, are you a valid server? Yes. Okay, we've got that done. We use these random numbers to start generating the pre-master secret. So we're all in the asymmetric encryption part. Then we generate finally a key. We exchange the key, make sure we're good. Then we start exchanging the data using probably AES 256, I think is the current one that we use. Pretty sure. For websites. This one probably uses AES 128, I believe. And the more bits, of course, means, whoops, I went to the wrong place. If 128 is this long, 256 is going to be this long. And length makes a difference. It doesn't show it in here. I must need to get Firefox back or something, because that will show all that information.
was
And-
bar maybe there.
I don't know, usually it'll say all that stuff.
Was a scroll bar, we could scroll it down, maybe it's there. Certificate is valid, yeah, the certificate is valid.
That's where I was.
And details, and there is a big scroll bar. Yeah, here. We can.
This is all the certificate fields.
There is no information about.
Yeah,
Yeah, Firefox works much better here.
it gives you much more
A
information.
lot of
The
information.
only thing we can see is that we're going to talk about hashes today. It's using SSA 256 for hashes. Yeah, I'm gonna have to install Firefox because that shows all the information I want to show. Just not right now.